Alright guys, so we're going to go ahead and do some factoring practice, just a review of all the different methods of factoring. So here's our first case here. So we're going to focus on greatest common factor. Remember that greatest common factor is when you find the number or term that fits, the biggest number or term that fits into each and every term in the expression. So like for example, in this case, the biggest number that goes into both 3 and 5. In that case, that would be the number 1. So we can only pull out a 1 from 3 and 5. What about x squared and x? The biggest thing that we can pull out is x to the first power, because that's all we can pull out from this term, and that's all we can pull out, and we can pull out 1 from that term. So our greatest common factor is x, and so we're going to go ahead and pull out x. Oops. We're going to go ahead and pull it out from everything. So in this case, we're pulling out x, and then we have 3x plus 5. All right, and if you do the distributive property, you should get back to the original. All right, and that's how you get that guy. All right, and then in this case, number 2, you're going to pull out the biggest thing that you can pull out from 15 and 3 is a 3. So we can pull out a 3. We can also pull out an x squared. That's the biggest thing that we can pull out because we can only pull out 2 of them from here, 2 of them from there. So we're going to pull out an x squared, and that gives us, so 3 from 15, that would be 5. And then we have 1 more x left over, plus, and then we have a 1 left over because 1 times 3 is 3. And then we have no x's left over, so 5x plus 1. All right, and that's your answer for that guy. Alright, so that's the GCF. That's the most basic type of factoring problem that we'll encounter for the most part. So the next thing that we're going to look at, we're going to go ahead and look at trinomials. So trinomials of the form x squared plus bx plus c. So notice in this example, we don't have anything in front of that x squared, okay? So there's only a 1. Alright, so in order to do that, you're going to do kind of like the little Xbox method, right? So figure out the numbers or the factors of negative 15 that add up to 2. Alright, so 2 numbers that multiply negative 15 that add up to 2. In that case, that would be 5 and 3, and then it would have to be negative 3. 5 and negative 3 will give us 2. Alright, so we're going to do our double parentheses. We have x in each parentheses, and then you're going to use your 2 terms, positive 5, negative 3, and that's it. Alright. So in this example, here, let me go ahead and reduce this a little bit. Alright, so in this example, we have factors of 6 that add up to negative 5. In that case, that would be negative 3 and negative 2. Negative 3 times negative 2 is positive 6. So we got our double parentheses. We have x minus 3, x minus 2, and that's our answer for number 4. Alright, so that's how we factor these guys. Now the next set of examples is going to be doing the GCF. So pulling out the GCF before we even consider factoring. Alright, so for number 5, we're going to see what we can pull out before we even tackle it. So in this case, I have 2 3s and a 6, so I can pull out a 3 from each of these. So I'm going to pull out my 3 first, and then I have x squared, because 3 times x squared is 3x squared, plus x, and then I'm dividing 6 by 3 basically, so it becomes negative 2. Alright, now we can go ahead and factor this. So we're going to do the Xbox thing. So we have factors of negative 2 that add up to a positive 1, which in this case would be, so you can do positive 2 and negative 1. That would work out. So we have, don't forget that 3 out there. So we got our double parentheses. We have x plus 2, and then minus 1, x minus 1. Alright, so that's the answer for that one. Alright, so for number 6, we're going to go ahead and pull out the 4, because we can pull out a 4 from these two 4s, and we can pull out a 4 from 120, because 120 divided by 4 is going to be 30. So we got 4, we got x squared minus x minus 30, because 4 times 30 is 120. Now we do the factors of negative 30. That add up to negative 1. In that case, it's going to be negative 6 and positive 5. Alright, so we got 4, we got a double parentheses, x minus 6, x plus 5. Alright, that takes care of number 6. So now we're going to go ahead and move on to factoring by grouping. So in this example, we have multiple terms. We generally have 4 terms, okay? So you want to look out for things where you have 4 terms. In this case, you want to basically put a parentheses around each set of 2 terms. Alright, so in this case, what can we pull out of the first group? From the first group, we can pull out a 2, because 2, and you can pull out a 2 from 2 and a 2 from 4. We can also pull out 1x. So we can pull out a 2 and an x. And we have 1x left over, we have a 2 left over, negative 2, and we have no x's left over because we pulled out an x. We can pull out a 5 from 5 and 10, so plus 5. 5 times x is 5x, 5 times negative 2 is negative 10. Alright, so in this case, these two match, so that means that takes the place of one of your parentheses. Your other parentheses is going to be given by the terms in front of each group, which is 2x plus 5. Alright, so we're going to do the same thing here. So you make your 2 groups. Alright, we can pull out an x squared as well as a 3. So we got 3x squared. 3x squared times x is 3x cubed. Got a negative there. 3 times 2 will give us 6, and then there's no more x's. We can pull out a 5 here, and we get x minus 2. Again, these match. If these match, you're doing everything correctly. So one of your things is x minus 2, and your other factors given by your 3x squared plus 5. Alright, there's your answer. So for number 9, so the next set is factoring trinomials that are a little bit more complicated. So here you're going to have a term in front of the in front of the x squared. So a cannot be equal to 1. So in the normal case where it was x squared plus bx plus c, that was before, that's where a was 1. This time a is not 1. So like for example number 9. In this case you're going to use the AC method. Alright, so you're going to use the AC method. So you basically multiply your a and your c together. So you multiply those. So we have 2 times negative 10. Alright, so 2 times negative 10 is equal to negative 20. And then you find the factors of negative 20 that add up to positive 1. Which in this case would be, should be 5 and negative 4. And then what you do is you split this middle term here. So let me erase this stuff here. So you're going to replace this middle term into those 2 terms, 5 and negative 4. And you're going to bring everything else down. Okay, so you bring this down. So we have 2x squared. Now that middle term breaks up into positive 5x. Don't forget the x there because this is x. And then minus 4x. Bring down that guy, minus 10. And then you're going to factor by grouping, which is what we did earlier. So you're going to go ahead and make your 2 groups. Make your 2 groups here. Alright, so we can pull out a 2x here. So let's pull out a 2. Oh, I'm sorry, we can't pull out a 2 because we can't pull out a 2 from 5. So we can only pull out an x. Alright, so we got x, and then we have 2x left over. 2x times x is x squared, 2x squared. And then we can pull out an x here, and that'll give us 5. Now we can pull out a negative 4, okay, because this was negative 4 here, that's a negative 10. So we can pull out a negative 2 from negative 4 and from negative 10. Alright, so negative 2 times positive 2, gives us -4, and we got an x left over. And then -2 times -5 gives us, I'm sorry, +5 gives us -10. All right, so -2 times +5 is -10. And then these match, which means you're doing this correctly. So we have 2x plus 5, and then again use your the terms in front of each group, and that gives you, here, let me erase that, gives you x minus 2. And that's your answer. Now for this guy, again, we have an a term in front of the x squared, so we're going to go ahead and multiply these two terms together. That gives us 30. So we want to find the factors of 30. Let me put it over here. Factors of 30 that add up to 13. In that case, that would be 10 and 3. So we're going to split that middle term into those two terms. Bring this down. 6x squared. We have plus 10x, don't forget the x, and then 3x. Bring down to 5. Factor by grouping. So we can pull out an x here. We can also pull out a 2 from 6 and 10. So we have 2x, okay? 2 times 3 gives us 6, and then we have 1x left over. 2 times 5 will give us 10. We have no x's left over. Takes care of that part. Now we can't pull anything out here except for a 1, all right? So I'm going to pull out an invisible 1, but I'm going to write it out. And then we have 3x plus 5. Again, these match, which is a very good thing. So one of your factors is 3x plus 5. Your other factor is 2x plus 1, all right? So 2x plus 1, all right? That's done. So the next type of problem that we're going to look at that they can throw at you. Let's do it over here. So the next type of problem is difference of squares. So we call it difference of squares because you're subtracting two squares together. So this is a perfect square, this is a perfect square. Alright, because remember, the square root of x squared is x, and then the square root of 9 is 3. Alright, so these are perfect squares. So the formula for that, okay? So the formula for that is a squared minus b squared equals a plus b times a minus b. Alright, and so I'll show you how to do this. In this example, the way you can think of it, you can use the formula or you can use the method that we did with trinomials. Alright, so in this case, you can kind of think of this as x squared plus 0x minus 9, because you have no middle term, right? You only have a -9 and an x squared. So pretend that this is a 0. In this case, you want to find the factors of -9 that add up to 0. The only way that can work is if you had 3 and -3. Alright, which, see, in this case, that's your b and that's your negative b. So that's why you have the positive and negative version. So in this case, it would be x minus 3, x plus 3. Alright, so you can think of it as a plus b, a minus b, the formula, or you can think of it as the method that we did with the trinomials. Alright, so I'm going to go ahead and use the formula here. Alright, so what is the square root of 4x squared? The square root of 4 is 2. Alright, 2 times 2 is 4. And then x times x is x squared. What's the square root of 49? Well, 7 times 7 is 49. Alright, so that's our a in the formula, and this is our b in the formula. So then if we follow the formula, right, the formula is right here, then we have a plus b, a minus b. Alright, and there's our guy. Alright, so that's the easiest way to tackle it. So if you know that they're perfect squares, you can use the formula and then you're done. Alright. Next thing that that is generally shown is perfect squares. So for perfect squares, alright, this is where you have like a plus b squared. Like you have two of them. Alright, so in order to figure this out, what you want to do is you want to look at, well, you can do it two ways, right? You can do it the normal way. So if you do this the normal way, right, then you have factors of 4, that add up to negative 4. All right, the only thing that works here is negative 2 and negative 2. All right, so in this case you have x minus 2, which is the same thing as x minus 2 squared. And that would be your answer. All right, so you can do it this way. Another way to think about it is what you do is if you take the middle term, right, and you divide it by 2, then square it, and you get this guy, then you know it's a perfect square. So, for example, let me erase all this. So if you take the middle term, negative 4 divided by 2, and then you square it, so negative 4 divided by 2 is negative 2. Negative 2 squared is 4, all right? And we got this term. It matches up. If it matches up, that means it's a perfect square, and that means that you're going to take your negative 2 here, and you're going to put it squared. All right, that's one way to think about it. Okay, so you can think about it either way. As long as you get the right answer, it doesn't really matter to me. All right, but I like to show you both ways because it does end up helping you out in the long run when you're doing other methods. All right, so in this example, number 14, so in this case, if you take 8 divided by 2, right, and then you square it, well, you're going to get 8 divided by 2 is 4, and then you get 4 squared, which is 16, which matches up perfectly. So we know it's a perfect square. So we can just take our x, and then we can put our positive 4 in, and then squared, and then we're done. X plus 4 and x plus 4. So you can do this real quickly if you realize that it's a perfect square, and then you can go straight to the answer. All right, rather than trying to factor it and do the Xbox method. But either way works fine. Works for me. All right, but I just want to let you know because it exists. Another type of factoring problem is a sum and difference of cubes. So this is where you have a perfect cube. Okay, so a perfect cube, for example, the cube root of x cubed is x, because x times x times x is x cubed, right? The cube root of 8 is 2, because 2 times 2 times 2 is 8. All right, if you multiply it 3 times, then you get 8. So that's what we mean by perfect cubes. So that's a difference of cubes in this example. So the formula for that is a cubed minus b cubed equals, we have a minus b times a squared plus ab plus b squared. The formula for the sum of cubes, which is this number 16, I'll write it out here. A cubed plus b cubed equals a plus b, a squared minus ab plus b squared. All right, so we're going to use both formulas, one for 15, one for 16. So what's a and what's b? Well, a is basically the cube root of x cubed. So we said that that was x, right? So that's our a, quote unquote a. And then cube root of a, that's 2. So that's our b. All right, so in this example, we have a minus b, or x minus 2. All right, so we can go straight to the answer. So let's go ahead and show that. So we have x minus 2, that's our a and b. A squared, what's a squared? Well, what's x squared? It's just going to be x squared. All right, so a squared is x squared. A times b, so what's 2 times x? Just going to be 2x. And then b squared, that's going to be 2 squared. All right, 2 squared is 4. So we got plus 4. Done. All right, once you know that formula, you can go straight to the answer and you're good. All right, now let's do number 16. So let's go ahead and do the cube root of 8x cubed. And again, if you're not comfortable with the cube roots, we should be coming up on a chapter where we will do radicals. If not, I can't remember if we're going to go to radicals or not, but you know, hopefully we'll get to that part where we practice that. But in this case, we have a number that multiplies by itself 3 times to get 8, which in that case it's 2. And then cube root of x cubed is x. Now what's the cube root of 27? Well, 3 times 3 times 3 is going to be 27. So that's going to be your cube root, all right? Because 3 times 3 is 9, and then 9 times 3 is going to give you 27. All right, so now we got our a. Now we got our b, so we can go ahead and plug into the formula. So we have a plus b, which is 2x plus 3. A squared, so what's a squared? Well, what's 2x squared? Well, 2x squared is, 2 squared is 4, and then x squared is x squared. So that's going to go here, 4x squared. AB, so that's going to be 2x times 3. So AB equals 2x times 3, which is 6x. That goes there, minus 6x. And then we got b squared, which is, so b squared equals 3 squared, which is 9. So that's our last guy. Alright, and that is your final answer. Let's go ahead and go to the last one. The last two problems. So the last two problems are a combination, so you can combine the methods that we did earlier. So in this case, it looks like we have 4 terms, so it's probably a good chance that we can do a factor by grouping. So I'm going to go ahead and make my 2 groups here. So I can pull out an x squared, because there's 2 of them here and there's 3 there. So I can pull out x squared. So I have 1x left over. I didn't pull out a 5, so I still got a 5 there. I pulled out all the x's, so there's no more. Alright, here I got 2 negatives. Alright, so that means I'm going to pull out a negative. I can pull out a 4, because 4 goes into 4, and 20 as well. And we have an x left over, and then negative 4 times positive 5 will give me negative 20. Alright, so now we have, this matches up, which means we did it correctly. So we have x plus 5 as one of our factors, x squared minus 4 as our other factor. Alright, however, notice that this is a difference of squares. Alright, remember the difference of squares was a squared minus b squared equals a plus b, a minus b. So in this case I can go to x plus 5, that's for this guy, and then we have x plus 2, x minus 2. And that is our completely factored form. Alright, so now let's look at our next one. So this almost looks like a difference of squares. However, notice that we have a 4th power here. So really what we can do is we can rewrite this as x squared squared minus 16. See, in this example, you can kind of tell now this is my a. So we have our a squared, and then we have our b squared. Alright? So now a squared is going to be equal to x squared. Or I'm sorry, a is going to be equal to x squared. So in this example, a equals x squared. Alright? And in this example, b is equal to 4, because 4 times 4 is 16. So we're going to go straight, remember, we're going to use the difference of squares formula right here. So we have a plus b, a minus b. Alright? But as we witnessed earlier, this is a difference of squares again, so we're going to repeat the difference of squares formula. So we get x plus 2, x minus 2. And that's our completely factored form.